So we're very proud this year to be presenting the TETRAPYLON at the Gray Area Festival. As Josette said, you've probably all seen it coming in. If you actually look behind you, you can still see it there. This is a 3D printed sculpture, but also a virtual 3D model that was produced in collaboration between an Austin-based 3D printing company called Re3D, also with Creative Commons and the NEWPALMYRA project. And it's based on the work of Syrian-Palestinian Basil Kartabil. Since the general theme in the exhibition for the Gray Area Festival this year is distributed systems and blockchain, I also wanted to use this opportunity to explore the ways in which a work of art can exist in relation to these new technologies. So this is the exhibition view currently now at Gray Area Festival. But before we get to this work here now, I wanted to give you a general timeline for the TETRAPYLON. So Palmyra is a small city in central Syria. It's about 140 miles northeast of Damascus. The site is home to numerous ancient monumental architectural projects, some of which date back to the 1st and 2nd centuries when Palmyra was integrated into the Roman Empire. This is an artist's rendering from the 1800s that's actually not very accurate, but it gives you an idea for what people imagined it might have looked like at that time. And it gives you a little bit of a better view than looking at the sculpture itself. So this TETRAPYLON was erected toward the end of the 3rd century. It's a square platform, and on each corner there's a grouping of 4 columns, and the columns are holding up about 150-ton cornice. And in the middle there's a pedestal, which would have carried a statue, which may or may not have looked like what you see in this image. Here's a photograph from the actual site. This gives you a much better idea of the size of the TETRAPYLON against the human scale. And you can see in the middle here the pedestals which would have carried the statues. The TETRAPYLON was partially restored in the 1960s. If you look closely, you can see that the columns in these are actually concrete. I believe there's only one that's actually original. So even back then, there was still some intervention or maybe concrete 3D printing of the TETRAPYLON. In the 1980, Palmyra was designated a UNESCO World Heritage Site. Jumping ahead to 2004, a Palestinian Syrian computer engineer and open source contributor named Basil Kartabil began a research project in cooperation with the publishing company Alaus. Their project was to create a 3D model of a lot of the buildings in Palmyra. Unfortunately, the work was never released. This is a rendering from the Temple of Bel from that project, but we don't actually have any of the 3D data at this time. Basil would go on from this project to found Ikilab. It was the first hackerspace in Syria, and he later served as the project lead and public affiliate for Creative Commons Syria. Through his work, Basil kind of became one of the most visible open source developers in the Middle East and the Arab world, and he'd go to participate in projects throughout the world, including in the Middle East, East Asia, and Europe. Unfortunately, his contributions to free software came to an end during the civil uprising and the Syrian civil war. On March 15th, 2012, which was the one-year anniversary of the uprising, Basil was arrested in Damascus and imprisoned by the government without trial. While Basil's family and friends petitioned for his release, Palmyra broke into the global conscience again in 2015 when ISIL captured the city of Palmyra and began systematically destroying many of its prominent archaeological sites. This, I think, is the Temple of Bel after it was destroyed. And the TETRAPYLON itself was destroyed in 2017. Unfortunately, Basil was never able to share in the new creative output from the project that he started. After being imprisoned for 3 years, he was executed in secret in 2015 by the Syrian government, a fact that we didn't even know for another 2 years. The project itself, though, we consider founded in 2015. This is the URL. It's had a number of exhibitions throughout this time, some with the TETRAPYLON and some with other buildings from Palmyra. So even the TETRAPYLON that we see now is not the first iteration of the idea. It started as a 3D model of this piece, which was exhibited through the Victoria and Albert Museum at the Venice Architectural Biennale in 2016. The modeling work was by Ann Schneider and Jim Ellis, and it's sort of the cornice, but it's been chromed, and it was exhibited as part of the A World of Fragile Parts. The sculpture that we see now outside was printed by the Texas-based Re3D. It's composed of 25 separate pieces. Together it weighs about 200 pounds and is about 7.5 feet tall. And apparently it took about 800 hours to print. And they said it was, I think, the most extensive project they'd ever printed before. Looking at the model, it contains about 2.6 million vertices and about 256 million bytes of data, which maybe that sounds like a lot. It's only 256 megabytes. I say only, but size isn't really everything. But it's critical to understanding how a digital work like the TETRAPYLON can interact with a public blockchain like Bitcoin and Ethereum. So people often ask me, since I work in blockchain technologies, can we put the TETRAPYLON on the blockchain? I get asked this a lot. The simple answer is, well, no. But the question is, it's a more general question, which is, can you put a work of art on the blockchain? But it's actually an even more general question, can you put data on the blockchain? Because people say, well, look, it's a database, right? So can you put data in it? So I'm going to try to answer this question for Bitcoin and also Ethereum. So Bitcoin, let's start there. So in the blockchain for Bitcoin, the basic record is a transaction. This is sort of an illustration of the most common transaction type in Bitcoin. Here it's showing basically one input, which is, from Alice. She's signed. And it's going to 2 outputs. One is paying Bob, and the other output is going back to Alice. The transaction will have this information, the input and output, and it will also have a very simple script that's used to verify that the Bitcoin can be spent in this way. So this is sort of a code representation of the output, just the output part, which is like the pay Bob, pay Alice. So the first effort to add metadata to the blockchain actually abused this setup by writing a message into one of the outputs of the transaction. So normally it's going to have a hash, but you could just write arbitrary data there like, hi, happy birthday, John, or something in that, along with the timestamp as a birthday greeting. But this had a problem. So if you look at how the Bitcoin network works, in order for the Bitcoin to be spent, you have to find what's called an unspent transaction, which is an output from a transaction that has not been used as an input to another transaction. So if you have these kind of junk messages, like you just write junk data into it, the Bitcoin network doesn't have an easy way to identify whether the script is valid or not. So it would have to basically keep it in memory all the time. This had the potential to balloon the size of the mempool, and because you had these what are called not provably unspendable outputs for a transaction. So there was a innovation in the Bitcoin protocol to get around this called an op return. The op return is basically an opcode in the script that says that it will always evaluate to false, meaning it's not a valid transaction, it's not a valid output, which would tell the Bitcoin node that this is not a valid transaction and you can throw it away from the mempool. So within the script, there's an example here. You can fit about 80 bytes of data. That's not even enough for a single tweet. And considering that the average Bitcoin transaction is only 225 bytes, it's not really a very efficient use of a transaction to include metadata in it like this. So imagine if we wanted the TETRAPYLON to be encoded in these op returns. It would take something like 3 million transactions to do it. Somebody can probably calculate what that would cost. So an alternative to adding the file itself into the blockchain is to add some other representation of it. This could be something like a cryptographic hash of the file, and that would only take it would take 32 bytes to do that, and that would easily fit in the op return code. And the example here is something kind of like proof of existence, where you can take the op return, doc proof is sort of the protocol in ASCII, and then you can include the SHA-256 cryptographic hash of the file. So Ethereum, how would things work here? The situation for Ethereum is better than Bitcoin because you have more options for the data types and the structure of the data that you can store. However, it's still going to be prohibitively expensive to include a large amount of data on the Ethereum in an Ethereum contract. And this is kind of by design. In the same way that we don't want to be adding a lot of data to the Bitcoin network, we also don't want to be doing that for Ethereum. So we don't really want to upload a file to the network. We want to reserve the Ethereum contract for very valuable data, such as who is the owner, which address is associated with some information, et cetera. So here's sort of an example in Ethereum of what how an artwork could be represented as far as metadata goes. We could have things like the artist, title, maybe a hash, cryptographic hash of the file, et cetera, the year, and maybe some address that would be associated with the owner of the artwork. And this is kind of the best we can get on Ethereum, at least for now. We could add other information like ownership, usage rights, and maybe provenance information. But this shouldn't stop us from getting in, sort of diving into Ethereum from a development perspective. If you want to know a little bit more about the development stack for Ethereum, the main programming language is called Solidity. And some of the tool set uses things like Truffle, it's a Node.js framework, Ganache, which is a development blockchain that you can run locally, and then MetaMask, which is a browser plugin that actually gives you your wallet and lets you interact with websites that are programmed using Ethereum. But if you really want to learn how to create works or interact with a blockchain, you really have to approach it like studying a programming language. That's going to mean that you're going to have to look at things like data types. You have booleans, integers, addresses, things like this. You're also going to have to learn about the features of the language, control structures, events, et cetera. And then finally, learn more about how contracts work, what is available in the standard library, et cetera. So this is actually an example of Solidity. I'm not sure we've seen one. Rob kind of showed a piece of an old version. But this is the sort of a hello world Solidity contract. At the top, it has the programming version, the contract, sort of a state variable, the greeting, and then a function that you can call. I'm glad that Rob was here. Actually, I put this slide in before intending to talk about it, but he kind of beat me to it. This is actually the work that Rob was talking about in real life, where you can have the this is art, this is not art, and you can pay into the contract just with a simple transaction fee to change it. I didn't know if I should share Rob's code. It is open source, but it's always like, oh man, it's embarrassing when you show my code. So I rewrote it a little bit. Sorry, Rob. I rewrote this just so that it would compile with no warnings. So at least it's like, at least it's valid now. But he was 2 years ago, so things change. But this is now, code for Is Art by Rob Myers, and now, by Christopher Adams. But it's really not so scary. It's a very small, contract. So in comparison to, this like, well, can I put I have a work of art, can I put it on the blockchain? The answer is kind of like, well, no, or maybe you shouldn't. But can I create a work of art on the blockchain? The answer is definitely yes. And I encourage anybody who's, has a little bit, wants to get into programming to try this. For me, it's fun, and it kind of reminds me of like the early days of internet and web programming. So my conclusion about this is the blockchain is immutable and it's essentially indestructible, which is very unlike, the frail physical remnants of lost civilizations. So for this reason, it's kind of an attractive platform for the preservation of cultural data, although there are obvious technical and fiscal limitations to using it like this. And for that, I'll conclude. And